No, it would be a deleted podcast. Okay, so if it was x plus 3, you go 3 to the left. If it's x minus 3, you go 3 to the right. If it's the plus 3 at the back, you go 3 up. Minus 3, you go 3 down, right? So it's the opposite if it was with the x. We agree? Our vertical stretches, if it wasn't with the y, so we moved it over here, we took what it was. So if it was a 3, we had a vertical stretch by a factor of 3. We agree? Okay. Horizontal stretches flip. So you know how the sign flipped with horizontal translations? So if it was x minus 3, we said 3 to the right. Same thing happens, well, not same thing happens, but it flips as well with a stretch. So if it's a b, let's say, then we actually have a horizontal stretch by a factor of 1 over b, because it's just the reciprocal of it. So every fraction is over 1, right? Or every number is over 1. So b over 1, if you flipped it, would be 1 over b, right? So if there was a 2/3 in front, it would be a horizontal stretch by a factor of 3/2. You just flip them, okay? And once again, the points on the y-axis are invariant. Why would that be? Because that's where x equals 0, right? And where x equals 0, if I multiply by something, it stays 0. So they're going to be invariant. And if it's a negative sign, it's a reflection in the x-axis, or sorry, it's a reflection in the y-axis, not anything to do with the stretch. So describe the transformations that occurred here. So we have 5x, it's beside the x. So what do we get? A horizontal stretch by a factor of what? Yeah. About the, yeah, bless you. So if it's with the x, it's always about the y-axis, or it's a reflection in the y-axis. If it's not with the x, it's in the x-axis. What would be my mapping here? X, y would become what? X over 5 or 1/5 x, yeah. And then the y would just stay the same in this case because there's nothing outside that bracket that's different, right? So if it's outside the brackets, it affects the y. If it's inside the brackets, it affects the x. So we're going to look at 2x. The graph is, this is the original y equals f of x, and then we're looking at the one where it's 2x. So this is a horizontal stretch by a factor of, I'm going to go BAFO. Are you allowed to go HS BAFO on any type of written response? No. So it's a horizontal stretch by a factor of what? Move the big fat head out of the way. This is 2 over 1, so what's it going to be? 1 over 2 about the y-axis, because it's with the x. So my y's are all going to stay the same, and my x's are going to be halved. So this negative 2 is going to become 1 by a factor of. So actually, when your b value is big, it shrinks it because the b value is actually not the horizontal stretch. It's 1 over the b value, right? They used to do stretch and shrink, but they took that out so that you didn't have to say that, which makes life a lot easier because then you don't have to realize what it's doing. Does it make you understand it better? No, but that's why they just call it a stretch. Yeah, that's exactly, I bet you that's why. You nailed it right there. Shrink is another word for counselor, and they get it confused, obviously, like a psychologist. Yeah. Totally yeah. Nailed it. Okay. y equals square root x, then replace x with 1/3 x. So Remember we did the y equals square root x graph before? 0, 0, 1, 1, 4, square root of 4 is 2, 9, and 3. Now we want to replace the x with 1/3 x. So we're replacing the actual x in the equation with 1/3 x. I'm not telling you it's a horizontal stretch by a third. We agree? So I want the graph of y equals square root of 1/3 x. So what do I actually have? Horizontal stretch by a factor of what this time? 3. 3 over 1, or we can just put 3, about the y-axis. So our mapping is going to be xy becomes 3xy. So this is going to stay the same. And 1 is going to be at 3 now. Same height, but at 3. And my 4 is going to be the same height, but now at 8. Your x's get multiplied by 3, and your y stay the same height. So this would be 1, 1. It's now going to be 3, 1. Oh, times 3. I just multiplied it by 2. Stunner. Oh gosh, here? Still same thing. Look, just fixed it. Yes, 12, 2. I did by 2 for some reason. Example 5, I want to see how you guys can do with example 5 and example 6. Do example 6b if you aren't doing something in pencil. For sure, do example 6b in pencil. Okay? Remember, you're basing it off of what was already there. So this is already there, right? So you're not going to say transformations on the 4 because it's already there. So try these ones out, see how you do. Okay, so this is in the bracket with the x. So this 3 does what? What does that 3 do? What kind? So we'd have to do SRT, CERT, or the other form. Snap. And then we have vertical stretch by a factor of. I repeat, are we allowed to write VS baffle on our test? No. 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 That's a definite no. That doesn't even, no amount of pi. We'll make that be okay. No. Vertical stretch by a factor of 3 about the okay. This is with the x. And it's with the x because it's all to the 3, right? So that's how we know it's with the x. So it's a horizontal stretch by a factor of about the okay, 6. Is there anything with the x currently? No, the x is just by the squared. So what I'm going to do so that I don't think something's with it is I'm going to put a bracket around it. Just like that, so I know it's by itself. If it wasn't by itself, they would have a bracket around it, right? And they don't. So I'm just going to put a bracket around so I know there's no x's, any x change happening here. So actually my mapping is going to be still x comma something, right? But the x is going to stay the same because nothing has changed with the x. All right? So stretches. What do we got? A vertical stretch by a factor of 2 about the do we have a horizontal stretch? No, we have nothing with the x. Reflections. We have a reflection because it's not with the, right? Translations? Vertical translation, 3 up. So my mapping is going to be xy will become x, comma. Remember, SR multiplies T, adds or subtracts, right? So we have a stretch by 2 and a reflection. So what are we going to multiply our y by? Negative 2y. And then we're going to do what? Plus 3. So if you have your transformations written out, your mapping is just what those are. Because you're just doing what you're saying, right? Okay, this one's tricky. The reason why I told you to write this one in pencil is because the negative 2 is not sitting out in front. Okay? You actually have to remember to do this, and they'll rewrite that. They'll give you questions like this all the time. The horizontal stretch, remember the rule with horizontal translations is you had x plus something or x minus something, and then you stated your translation, right? Do we have x plus 4? No, we have negative 2x plus 4. We agree? We need to have a 1 in front of that x in order to state the proper transformation. So we'll always get our stretches right and our reflections right, but our transformations are going to be wrong if we don't remember to take that value out. So what are we going to get? We're going to get y equals negative 2 bracket x. And when you're taking a GCF out, what you're actually doing is dividing, right? So you're going to go 4 divided by negative 2, which is negative 2 bracket bracket squared. And now you'll actually get your horizontal translation correct. You have to have a 1 in front of the x in order to state your horizontal translation. Okay? So if they don't have it, that value taken out, the horizontal stretch taken out, you have to remember to take it out. Do you think they'll have the answer to it not taken out? Absolutely. So, S. What kind of stretch do we have? It's all in the brackets with the x. And some of you say, well, is this still with the x? Well, is this still all to the 2? Yeah. So still with the x. When you take it out still with the x, it doesn't miraculously become a vertical stretch at that point. Okay? So it's a horizontal stretch by a factor of what? 1 over 2. Yeah, it flips. About the, it's with the x, so it's about the y-axis. It's negative, so we have a reflection on the y-axis. Translations? Horizontal translation to right. And our mapping would be xy becomes what? Stretches and reflects multiply. So we're going to multiply the x by negative 1 over 2. X, what? Plus 2. And then just y. C. Stretch? No. Reflection? No. Translation? Yes. Vertical translation, 1, what? Up. Horizontal translation, 2, right. So my mapping is going to be x, y. Anything vertical affects the y, anything horizontal affects the x, right? So I'm going to get x plus 2, because I do as I say. Y plus 1. Always do as you say. Don't be a hypocrite. Do as you say. Huh? This one, what stretch do I have? Is it with the x? Not with the x, so it's a vertical stretch by a factor of 2 about the x-axis, because it's not with the x. Do I have any reflections? Is there a negative in front of this 2 or a negative in front of the x? No, so the reflection is just going to sit. Do I have any translations? What do I have? Yeah. What kind of translation? my mapping. What happens to my x? Everything that's in the bracket, right? And anything that's horizontal. So I moved 1 to the left, so x minus 1. And what's going to happen to my y? To y, because whatever's out here affects it, right? And the y's just stay the same, so they're even easier. 2y. B. What's going on in B? Do I have any stretches? Any stretches? Nope. Any reflections? Yeah. The negative in front makes me have a reflection. So it's a reflection on the, yeah, because it's with the y, x-axis. Translations? B. Yeah. Now my x value is going to stay the same in mapping because my x has nothing on it, right? So x, y is going to become x, comma, what? What's the catch with C? Yeah. You have to take that negative 1 out. Because what did I need in front of the x? A 1. Is a negative 1 the same? No. So if you forget, negative 1's the ones that people often forget, but it's going to change your horizontal translation direction, right? So you have to remember to take it out. So you're going to get y equals f negative 1 x minus 3. So you are going to get stretches. Do I have any? Nope. Reflections? Reflection on the, it's with the x. Translations? 3. What do you think they're going to have as an answer? 3 left, because if you forget to take the negative out. Or also 3 left because you take the negative out and forget that it goes the opposite direction. All right. I'll give you some homework. It's on here. Actually, I don't want to do this. Sorry. I skipped example 9. I don't want to. Go to example 9. So they want us to write an equation. Write the replacement of x or y and write the equation of the image of y equals f of x. So if they give us a horizontal stretch by a factor of 6 about the y-axis, what's my equation going to look like? Y equals f of x is going to change to what? Y equals, nope, 1 over 6x. And often people are better for going from equations to words. So remember, that's fine. Once you get your equation, look at the equation and see if you get your words back. So now I look 1/6. Okay, that's 6. Okay, it's right. So if you were to put a 6 in there, you'd catch yourself going backwards, right? You'd be like, I have to flip it. Oh, goodness, I didn't. Okay, vertical stretch by a factor of 1/5. What do we do? Y equals 1/5 f of x. It's just the function f. It's any function f. I could apply this to now. So you can't type it in your calculator either to look at it. But it's just any function f. So it could look like this. It could look like this. It could look like parabola. It could anything. It's just a function. A reflection in the x-axis and a vertical stretch in the x-axis by a factor of 3. What would we get? Yep, f of x. Because it's a reflection in the x, it affects the y, and it's a vertical stretch, so it goes in front. Here we have a horizontal stretch about the y-axis by a factor of 1/2, and a vertical stretch about the x-axis by a factor of a quarter. So we get y equals 1/4, because it stays the same for vertical, right? F, and then what? Yeah. Like I said, if you're questioning yourself, look at the equation now and see if when you would give the answer to it, it would match. My goodness. So many extra examples. We'll come back to these ones tomorrow because they're just more of the... Oh, the reason why I put these ones in, once again, to remind you that if it's with the x, it affects it. So this is a 2, this is a 2, right? This is a 3x, this is a 3x. This is still a horizontal stretch by a factor of what? 1/3 about the y-axis. And absolute values, I've told you before, those are just like the brackets, right? Nope. You still have a reflection. It's going to take this original absolute value and it's going to stretch it and it's going to reflect it, but it'll reflect it this way. So it doesn't prevent the reflection because the reflection's in the positive y's, right? And if I had a negative in front, it's not going to prevent the reflection from putting it down because it's not in the bracket. So you'll still have the reflection, but it can happen because you can move positive y's, right? So this one here would be a horizontal stretch by a factor of 1/2, not negative, about the y-axis, and a reflection on the y-axis. And then the other one I want to do is this one. So I would move the 3 over. How can you move the 3 over? Divide by 3, which is also the same as 1/3. So I always like doing the multiplication, so I actually get it in front. I'm going to get y equals 1/3 x cubed. Is it with the x? No. If it was with the x, it would have been brackets. It's not with the x, so it's a vertical stretch by a factor of 1/3 about the x-axis. So I threw those ones in there too. But you guys don't need as many examples. That tomorrow. We'll look at the graphs, stretches and coming up with the graph tomorrow, just because it's harder. And then I'll give you your homework.